Hello guys, let's start with our module 4, data types and null handling. Let's start with the first video of the module, numeric data types. So from the name, as you can understand that we're going to study something about numbers, because numeric number, yes, you can relate those, right? So we are going to study something about numbers and about their data types or numeric data types. Fine. So let's begin with that. So let's start by understanding some theory. Okay, what are numeric data types? Numeric data types are used to store numbers in a database. Then choosing the correct data type is important for accuracy, storage, efficiency, and performance. Okay, so I hope you understood this. Like, numeric data types are used to store numbers in a database. Like, choosing the correct data type is important for accuracy, storage, efficiency, and performance. Because what kind of data type you are storing, a database should know, right? Suppose it's like, uh, you should know about your car, of what engine and of what specification the car you are using is of, right? Similarly, database should be knowing of what kind of numeric data it's storing, so it should be knowing the data types, right? So it becomes easier for the user also and the database also to interact with each other, as if a person knows that I am storing an integer data type, because database also has the integer data type for a particular column. Okay, so this is how the accuracy and storage and efficiency is storage efficiency and performance becomes much more crucial in this particular thing. So let's move ahead. Let's start with the one main categories of numeric types. Okay, so let's start learning about this now. Okay, let's start with um, what I will do. I will just try to type it out. Okay, so let's begin with A, which is integer types. Okay, I'm writing here in this manner because I want you that you can have the proper notes or the whole numbers. So here I can just add a point that uh, it is used uh, when you don't need decimal values, and we all know what are decimal values, right? So I'm not going to explain that. So let's move ahead. What I can do is that I can bring down a table here so that it becomes easier for you to look at the list. Okay, so I have brought down this list for you. Now here you can see that the data type are of these types, right? Four data types, which is tiny int, small int, and big int. And I am pretty sure that you might have heard about the int data type. Okay. Now here you can see each data type is basically a kind of a class. Class means if you have coded in C++, Java, or any kind of a programming language like Python or anything, there we create a class, right? And it has some kind of a storage when it is used. Similarly, here also this int, big int, small int, tiny int, every particular data type has a storage. Of like tiny int has a 1 byte, 2 byte, 4 byte, 8 byte. And now, why these bytes and the storage are crucial? Because even the database is used to store the data, but if the data type is heavier, it will take more time to fetch data, right? And it will also take more space to store the particular type of integer data. Suppose if 8 has 4 bytes, right? suppose this is a integer 8, okay, it has size of 4 bytes, as we can see from here. Now if I have 8 and if there are thousands of rows, then automatically 4 will be multiplied by 1000, it becomes 4000 bytes of space is used. Simple as that, right? And also you can see the range here, and I have written here signed. Now there is signed and unsigned integers, okay, or yeah, signed or unsigned integer, you could say that way only. Signed means you have positive and negative values in it, okay, and unsigned means it starts with 0 to the positive max, fine, like infinity. So that is why if you can see here the range for tiny int is of -128 to +127, and small int goes from -32,000 to +32,000, and int goes from -2.1 billion to 2.1 billion, okay. And big int, it is of 8 bytes, and it's very large numbers. These are very large numbers, literally. So suppose this is on billions, right, the negative to positive. So what will be the value of big int, right? What I will do, I will give you this all the ranges at the end, or let me at the end I will give you all the ranges for now, no full ranges, if there is anything else also, so that it becomes easier for you to go through it. Right now you can just focus on this important storage and ranges of the integer types, okay. So our first category is done, okay. Let's move ahead to the next category. I hope you understood this, right? It's pretty easy and straightforward. You just have to see it, remember it, and understand it. That's it. Nothing else, nothing much more complex. Let's start with the second one, which is decimal or fixed point types, which means that exact values. Why exact values? Because when we write in decimal or in a fixed point, suppose $19 or 19 rupees 0.99 cents or 1 cent, right? So that is like 19.19 cent. It's an exact value, right? It's not round up to 20 or round below round up to $19, right? So that is why it is written that way. So we'll just write here something like it is used when precision is required, and especially when precision is required, especially money. Yeah. So there is something like this type and something like best for, okay. So here it is decimal, the type is decimal, p comma s, p comma s. I will tell you what is p comma s, and these are best for uh, currency, financial calculation, okay. What does this p stands for, okay. P is basically total digits, and s stands for digits after the decimal point, okay. For example, let me just take an example here. Example, salary column has this decimal with 10 comma 2, which means that meaning means maximum 10 digits and 2 after decimal. So it is like 10 digit, right? 1 1 1 1 4 5, 4 times 1 5 6 7 8 9 10.22. So this is the way it will look like, okay. So I hope you got it. Now if so, it's like we are in decimal and fixed point, right? Now someone might say that why are we not using float? Okay, that means you have the understanding of the float data type, and the people who don't have the understanding of float data type, don't worry, but to whom it might matter, like to whom who knows why we are not using float, and or else they know the meaning of float. So I can just write here uh, why important? Okay, because money should not be stored in float because rounding errors can occur. Okay, this we will understand when we will study about float, but yeah. So let's move ahead and study about um, float now. Okay, C, floating point types, which means approximate values. Approximate values. Okay, now these are used for scientific or approximate uh, calculations. Okay, so I pasted this thing here. So what it basically is saying that the type is float. Like in floating point types, there are two types: float and double. Fine, and here you can see float and double. Now again, same thing here. Float has the bytes of 4 as storage, and double has 8 bytes. Now, what is accuracy? Accuracy means approximate and more precise than float. Approximate means something like $88.98 or something like that, right? And whereas double means 88.9777777 something, right? So this all 7 was converted to 8 in float, but in double it remains the 77777 as an approximation. So this is a major difference between them, that they are more precise than float. Okay, so you might be thinking that the things are going in a bit shortcut manner, but it's not. It is what it is. They are nothing to more worry about some topics, right? In every topic it is not necessary that you might be studying a lot of things. It is what it is. There are some simple topics also. So what are the use cases for this? mm, First could be temperature readings. In temperature readings you can use it. We can use it in scientific data. Okay, so this is about float and double. And I just forgot to mention about the example here. Let's take one example here also. Or the use case, I would say, like use cases could be in SQL, when I am taking an age of a person, when I'm taking the student role, okay, when I'm taking the large IDs in age, the data type might be tiny int, because age is, no one is going to be more than 127 of years in today's world, right? So so here I might be using this tiny int, and for the roll number I'm going to be using int, because roll number could be more than billions when we write the series, right? Large IDs would be big int. So this could be the example or use cases where you can use this kind of things. Okay, coming back to floating point types. So I explained you all the floating point types, like which are float and double. For decimal fixed point, I explained you what is decimal and what decimal p comma s stands for. Correct. Then I explained you integer types. These are the main categories of numeric types. Now let's move ahead and look at uh, two- okay. Let's look at unsigned numbers. Okay. By default, integers store both positive and negative values. As we show previously that uh, there was minus 128 and it was going till 127. So integer was storing both negative and positive values. If your column will never have um, negative integer, like age cannot be a negative, right? Age cannot be negative. uh, what else could not be a negative? A roll number also logically cannot be a negative number, right? And other than that, a weight cannot go in negative in normal world. a normal scenario, integers. Okay, so if your column will never have negative integers or negative values, use unsigned, because unsigned stores only from 0 to positive infinity. Okay, example could be um, in SQL, like age is tiny int, right, and it will be unsigned. So if someone tries to put a negative age, it will throw an error. Okay, so it is also a security or protection also. So this was all about the unsigned integers or unsigned numbers. Don't worry, we will be looking at the examples, but I'm trying to go through the theories or whatever the small notes I could give you so that you could have the understanding of the things. Now let's move ahead. Let's look at the third point now, which is choosing the right type. Okay, so here I'm going to list few example kind of a points so that you know when to use what kind of a data type. Okay, like let's start with use int for general counting and IDs. Okay, then use decimal for money and exact values, right? 3, use float double for measurements where slight rounding is acceptable. 4, use the smallest type possible for better storage. Okay, so these are the things you should keep in mind. Okay, and also like earlier I said that here why money should not be stored in float, because rounding errors can occur. Because what happens in floats is that they round up the values, right? So if it is suppose if it is $19 0.89 so it might get round up to zero point 0.9, right? So there is a difference of 0.01, right? So that is not good in the case of money or in the case of a very precise values, right? So that is why we don't use float in those particular scenarios. Rather we use double. Okay, so this was all about these three things. Now let's move ahead and look at the examples now. Okay, let's move to the MySQL workbench. And I would say still you don't have to worry about anything because we are just going with the theories and looking at the examples, right? We are not practicing exact syntax and keywords of the SQL. So if you don't understand, don't worry. Either you can Google it or you can just look and watch. You will get the idea because SQL is not that hard. Uh, let's start with the first example would be of integer types, okay, or the whole numbers again. Okay, we'll paste this query here, and here what I'm trying to do in this particular query, if you can see example, uh, student age, it is of tiny int, correct? Look, age is tiny int, and if you can just look at the student ID, it is int because IDs could be of a longer values than 32,000 also, right? There could be ID of value 111111. It's possible, it's not a big deal, right? Because it's a number. Okay, so let's move ahead. Like here you can see we are using int for the ID. In example also I explained you about this, and for the age we are using tiny int. Okay, we'll just run this. Okay, okay, forgot to select the database. Fine, use school db. School db is in use and I will create this now. Okay, so yeah, it is created now. If you can go to the tables, we refresh it, you can see that student is there, right? And if I go to the column section, I can see the type of student ID is int and the age is tiny int. Okay, I hope you're getting this point. So I gave you the example of int and tiny int, and let's look for the big int. Okay, I will create another table here, and this will be for um, big int. Okay, and here tiny int and int. Okay, we'll just run this query. It created another table of name as transactions. If I go here, if I go to the columns, and if I look at the text ID, it's big int. Okay, because text ID could be of big integers. Fine, means more than billion. Because if you have seen transaction IDs, uh, how does it looks like? If you have looked at the transaction ID, how does it look like? It are those are very long numbers, right? Something like this. Uh, uh, TXN ID, then 1 2 3 4 5 6, some random variables. So this becomes a very large kind of an integer, right? Sorry, not the characters, only the integers are there, right? So it becomes a large integer. That is why in that scenarios we use Binkit. Now let's see, this is for the integer types. Now let's look for the unsigned integers. Okay, unsigned numbers or integers, whatever is fine. Only positive numbers. The marks cannot be of negative, right? Negative marking could be there, but marks cannot go below 0, right? Everyone knows that if something goes below 0 in marks, it is basically round up to a 0, right? So here, that is why I've taken an example here. Student ID is int and marks is tiny and sign int. Okay, and what I am trying to do here, let's first create this table got created. Okay, this exams table columns, like student ID is int, marks is tiny, unsigned. Okay, now what I'm trying to insert a value of 95 of the ID 1. I will run this, and again I will refresh. If I come here, if I just click on this, look, 95 marks, right? Now in the same table, what I will do, I will insert this. First I will put some negative values here and let the ID be 20. Okay, I will run this line. Look, it throws an error. Out of range value for column marks at row 1. So if you look at then if you go to the data type and if you check that marks is tiny in unsigned, un means unsigned. So that is why you cannot put negative numbers in it. Okay, and here also, if I just run it again, it's still the same. Okay, now let's look for the third one, which is um, fixed point type. Okay, basically the exact values. So we'll paste this query here, and okay, so here you can see that in fixed point we're basically looking for decimal p comma s, correct? So what I have done here, I've created an employee table employee. We don't have employee table here, right? Yeah, and employee ID is int, and salary I put that in decimal because precision is required. And I will run this directly and also insert the values in it. Okay, so everything is done. Now we'll refresh. Now you can see there in employees table is created with this particular SQL query, and with the help of insert query I inserted the values. Okay, what you can see here, employee ID is int, salary is in decimal. Fine, but if I just want to look at the values, I will click here, and in employees table we can see that we have two this, right? Now what if uh, suppose 72,000, right? I tried giving this and it is 10, right? So it's 72,000. Let me give some bigger value, right? What's an issue? 5 6 7 8 9 10 11. Okay, so already I'm taking 11 values here, and let me also change this ID. So out of range already we can see it's 11. Now will it enter the value of the table or not? We will check that. Look, it throws an error. Out of range column for this value range. Okay, for salary. So now how many digits we have? 1 2 3 4 5 6 7 8 9, correct? 9 10 10 11, right? So again I have to reduce one digit. Now will it throw an error? Let's see. It won't, because This is 8 and plus 2 gives me 10. So total becomes 10 digits. So that only I will write it again here. Okay. P means total digits including the decimal point. Okay. Then S means digits after decimal point. So example, if P is 10 and if P is 10 and S is 2, therefore it becomes 8 plus 2. Okay, so 8 becomes the before decimal after decimal. Okay, so I hope you got this point now. So coming back here once again, here also I explained like here that total digits. So I will write it much more clearly here, or what I can do, I can just copy from there. Okay, I will just paste it here. Okay, uh, here the information was not bit clear. Now I think it will be clear, and I will just remove this also because it should be 8 plus 2. Okay, also I will just take this and paste it here. Great. So I hope this will make sense now. I might have missed this particular thing. Coming back, let's move ahead now. We did tiny int, we did int, we did big int, right? We did the unsigned also. We did the fixed point, which is decimal. Now let's move with the floating point, which is okay. Floating point types. Approx values. Just paste this query here. Look, I have created a table here named as weather, city, varchar. Just ignore this varchar now. And temperature is float. Okay. This is also a type of data type which we will study in the further videos. But currently focus on float, which is a floating point types. In floating point types, how many we have? We have float and double, right? Okay. So I will just create this. Table is created. We'll refresh it again. Okay. We have the columns here, city and temperature. Now we'll add these values. Now values are also added. Great. Now we'll open this thing. Look, 0.3, 35.6, right? Let's try adding another value. Let it be Mumbai only. I won't, or let it be London. Okay, and let the temperature be 29.31 or 39. Let's see what happens. Does it rounds up or does it keep it same? Ah, it keep it same, right? This is how float works. Now let's look at the double also. Now in float, suppose I try to insert another thing, right? Let me copy this and paste it again here. 39, right? If I think of giving more precision, suppose 111.000.222, will it throw an error or will it pass? Let's see. It passed, right? And let's come here and check. Look what we are getting. Output as 29.3111. But I remember putting as it as 11110000222. Where is that value, right? So what it does, it basically rounds up, right? So this, so it, since it was a smaller value, it didn't round it up, but this got rounded up, right? Now if I take the example of double, okay, this is a double example. In the example of double, I will create a table named as science data, okay, and look here, everything is this way, right? And this is a measurement. This column is measurement column, correct? Let me run this. Okay, yeah, look, 000, everything is 00, then 1 2 3 4 5 6, right? Random values I put there, but everything is there, right? So that is why, because in double it didn't rounded up anything, because it takes the complete precision of the value. Fine. I hope you got the difference between float and double more clearly by looking at the practical example now. Okay. Now I'm more interested in sharing you with the ranges of the all the types of data type we studied. Okay, so what I will do, will come here and I will just add a page. Like for the sign integer, I will paste this. Okay, what I'm going to do, I'm going to paste all the ranges. For example, for the integer type ranges, for the signed, unsigned, decimal and floating types, right? And make a list for you so that you can go through it and you can memorize if you want, but it's not necessary. You can go through it and it becomes easier for you to understand and read that. Okay, then we will move ahead. So okay, so I have pasted here all the minimum maximum value range. What is the range of decimal floating types, right? For decimal how it goes, for floating how it goes, for double how it goes. So this will help you to go for a revision. Okay, if you just want to go for an overview, like if I can see here, I have already provided here, but some since it's all together, so it will be easier for you to study and move ahead. Okay, I have one or two things to let you understand, like few topics. Let understand this difference between decimal and float. Okay, so what is the difference? Both, both stores the values in the same manner, right? Like 888.020304 or 06, like the number of decimal points we allowed it to go with, and along with the float also, right? So what is the main difference? What is the main difference? Decimal, exact precision, okay, and float, approximate, approx precision. Now, why we have not taken double? Because double is the most safest exact precision giving data type, as we have seen already in the example. Uh, like to make it more clear, what happens in float? If the value is suppose 0.30000 0004, okay, this will get converted to 0.30. Fine. But for decimal, we will already say it that we have some values and the precision is required is 30. So look the difference, because we gave the decimal the values, right? P comma S. Got it? Here rounding can happen. Okay. In float, rounding happens, correct? We already saw the example also. But in decimal, no rounding, correct? Because we give the precision, right? We need two decimal places at least, correct? So as we saw the example, this will get round up to 0.3, but this will remain as 0.3.0, right? We cannot add more than this value, it will throw an error. So this becomes the main difference between the decimal and float. I hope you got the point. It's pretty easy. It's pretty easy. Just I wanted to remind you about that. And we also study about the sizes. Like we got the ranges here. We got the sizes of the storages, right? And if we go back, like here for the float, I gave the size. For the double also, I gave you the size, right? And for decimal, there is no size. It depends upon the precisions what we are using. So that does not matter. Now overflow concept also we saw, right? Let me write it here. Next page. Overflow. When uh, value exceeds the allowed range. We saw this example in the MySQL workbench, right? Range of a data type. Fine. Suppose if it is example, if age is tiny int giving 200 error, because the range is from 128 to 127, correct? So this applies for all the kinds of data type because it depends upon the range. So please go through the notes, whatever I have given here. It's pretty much, it's sufficient from basic to advanced understanding, because this is it. You already know because you have to just know about the types. So this is all about the numeric data types, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is character and string data types. Okay. So in this particular topic, we are going to understand the data types of character and string in SQL. Okay. So let's move ahead and let's begin with the definition first or a statement first, right? Let's begin with something. In SQL, character, string, data type are used to store text values like names, address or addresses, emails, descriptions. Okay. So in SQL, character string data types are used to store text values like names, address, emails, descriptions, right? And also these data types are essential because not all data is numeric. Most real world databases store a lot of human readable text. Okay. So let me write this also that these data types are essential because not all data is numeric. Correct? Most data, most we say real world data bases stores a lot of human readable readable text. Okay. So this was just the intro of characters and string. Like in SQL, most of the character and string data types are used for storing names, addresses, emails, descriptions, and also in the data types. In these data types in real world, not only stores the database not only stores the numeric forms, right? No numbers, string, numbers, and all that, but it also stores strings. And as we go forward, we'll see rather than numbers, it is storing much more number of strings compared to that, right? Character and strings. So this becomes one of the important data type to know about and learn about. So let's move ahead. Let's start with main string data types. Okay. So let's begin with the one. We'll just type it out. It will be much more clearer and easier. With let's start with character, char n. Okay. This way. Fixed length string. When we basically the statement reads itself, right? It's like that. It stores basically stores exactly n characters. Okay. Second, if the value is shorter, SQL adds up spaces, or you could say it as padding. Okay. For example, suppose character or char short form. This basically this n. Let me tell you this. This n represents uh, size. Okay. So what I will do for this character, let it be size of 4. Just that. And I have a specific codes which size goes from 1 to 4. Okay. So suppose if I write A, B, C, D, great. But if I write A, B, C, then if I write A, B, and if I write A, okay, then what will happen? This is a padding. Okay. This becomes padding. Padding. Because because the size 4 is already initialized, right? Whether you use it or you don't use it. That is why when we use char, we have to keep in mind that the length is always fixed and exactly equal, or one or two value up and down. But has to be equal. Otherwise, you cannot just waste spaces, right? By using padding and all that, by having padding in that particular scenario. So that is why this is it. And I will just write it down here that I will just write the use case also. Use when data length is always fixed. Okay. For example, if I take an example here, let's take gender. Suppose gender is a column name, okay, with the char as 1, okay, and country code with char as 2. And we know that worldwide gender is represented as male and female and T as transgender sometimes, right? And country code is also represented in two words most of the time. Sorry, not words, two characters. Like suppose if it's India, IN. If it is USA, it's not USA, it's US. Then UK, Europe, EU, right? So it goes on. It goes on, right? So this is how it is used. Now, to keep in mind, fast. It is fast for a fixed size data, okay. And also you have to keep in mind that wastes, as I already said, it will waste spaces if values vary, correct? It will waste the space. So these are the, like, I could just write it as note. I can just write it as note as the heading here, okay. So I'm writing it in this manner because I want you to have a clear script for your revision. So this was about the char data type in character and strings data types, okay. And I hope you understood this example which I took it in the right hand side. Now let's move ahead and let's try to understand the second data type, which is varchar. Again, and here it basically means variable length string, okay. VAR means variable in the short form, it's VAR, okay. So you could also call it as variable characters, okay, but variable length string makes much more sense. So it basically stores text up to n characters, of course, because the size is that only, right? Then, but uses only required space. I will make you understand this. And it also it is note. It is also a most um, what I can say commonly uh, used string type. Okay. Now, what I meant by saying that uh, it uses only required space. Okay. How it uses required space only. For example, if your varchar is of length 6, just an example, then, and please keep in mind this n basically represents the size, okay. Should I write it somewhere? Let me write it somewhere. Wait, n, this represents size. Fine. Now I will write again varchar suppose 6, okay, and I have a word of letter 6. Suppose A B C D E F. Fine, you realize this complete space. A B C D E, A B C D, A B C, A B A. Okay. Now what happens is that no padding is considered here. Okay. Initially, what was happening in the char that the padding was taken under consideration, which means that if the varchar of 6 size is initialized, that means whether you write A or whether you write A B C D E F, it will take the size as 6 only in character or char. But in varchar, it is kind of a dynamic, I could say, right? So this what I can write, no padding, okay. So there is no padding in this scenario. So if you write A, so varchar 6, but you wrote there AB, right? So it will only occupy 2 spaces, not 6 spaces. So this is a efficiently, or you can say this is an efficient type string type which you can use as per the requirement. Okay. Let's so moving ahead, let's take an example also. Suppose name could be a varchar, right? Because we don't know what people names are, so we just put a default as 50 is the size, right? Email also, we don't know what could be the length of the email, right? So that's why we are using varchar in this particular scenario with the length of 100. Okay. So how this helps, we'll just write here as note. It helps with or saves storage, as you can already figure it out, and best for names, etc., or I could say dynamic content. Okay, so this makes sense to you now, I hope so. Okay, so this was about the varchar and the char types in string. Now let's move ahead and try to differentiate both of these, right? What I will do, I will just write here char, and I will just go in the end and I will write as varchar. Okay, and before that I will just mention here key difference between what, between character or char versus variable character or varchar. Got it? Now let's go with the differences. So let's start. Okay, so let's start with the length first. Length, the feature, right? It is fixed here. What is here? It's variable, correct? Second, space. Space is always n. Only actual text, right? Third, best for codes, as I said, right? Codes, flags, and these are best for names, addresses, etc. Okay, so this is the key difference between char and varchar. So if anyone asks you in an interview or even in the corporate that why you're using char and not varchar and vice versa, just tell them this, that man, this is the basic thing you should be knowing. So that is why I'm using char or varchar. Okay, so now let's move ahead. Let's look at the third one, which is text. It is large text data. Okay, it is used for what? Used for storing long descriptions, okay, or paragraphs. When there are characters, like you will say that why not use varchar and put 500 as a size, right? We can store up to 500 characters, but text gives you more power. It can store up to 500 words, so there is a difference between the words and the characters, right? So I hope you're getting that point. And putting much more size on the varchar becomes inefficient when the data is too much, right? So that is not a good practice, I would say. That is why people has made these three different figures like char, varchar, and text, correct? Also, let's types, and also I just wanted to specify something like types in MySQL, I would say, or SQL. In both, basically everything is kind of the same. So it's like text. We'll just write here as type. I'll go here and write it as max size. For type, suppose it's text, medium text, long text. From the word, you might get the idea that text might be storing, suppose x. So medium text x plus 1, long text x plus 2, something like that, right? Size would be around like 65 KB for it. Look, now it's much more clearer. Here size would be about 16 MB. It's a lot. It's a lot of difference, I would say. and here size is about 4 GB of text. So this is the types in MySQL or even in SQL also, but in MySQL these are the three types. Since we're going in MySQL, practicing in MySQL, so I thought of giving this also here. Okay, and if you go with an example, the example would look like something. Suppose your column name is description, and I will write it as text. Okay, so this is the way it's done, and also it is useful for blob content, feedback, and notes. Cannot and cannot be indexed fully like varchar. Okay, so this is the difference between them. So I will just write it as note. Got it? So this was all about the text. Look, there is not so much to understand in this thing, this kind of data types. You don't have to go in depth because there is nothing, right? But I'm trying to give everything what I know. So you know everything from every corner. So it is not difficult for you to move ahead. Now also there is another type of a string type, but which is not totally a string type, but I have considered this within this only, like blob storage I would say, or its full form is binary large object. Okay, it stores binary data like, can you guess, images, files, PDFs. Fine. So these are basically stored in the database itself. Yeah, you can store images, files, and PDFs in the database itself. For example, if I give an example how it will look like, it will something look like profile pics. For example, I will write it as blob, and everything will be set up in the MySQL or SQL, wherever, whatever platform you're using, and it will just go and put it there. But I also wanted to let you know that this, we'll put a note here. Yeah, there is an option for storing this, but it is not usually stored because it's ups a lot of space in the database and makes the database slow. So we'll write used less often in modern systems. Like today, if you go and store the files in this, suppose in MySQL workbench is a blob storage, everyone will say you, why are you using this and making the database inefficient to be used? Because today usually files are stored outside DB. Usually in today's time, I would say. Why? Because in DB, if you store this blob, efficiency decreases, takes lot of time. Okay, that is why it is stored in the outside of the DB, basically in clouds or something like that, or in some other RDBMS platforms. Okay, I hope you understood this part, blob also. So I also wanted to give you an information, like it's a kind of a extra information which I just wanted to share with you about the varchar, and I'm pretty sure you will never find this particular thing which I'm going to tell you anywhere in the YouTube or in any other courses, because it's a kind of a unique thing. Let me just tell you how. Very important and unique point. Okay, so I know I gave an heading a different way, but bear with me. I will write here that varchar, suppose 20, means 20 characters, right? 20 means 20 characters, 20 size, same thing, right? But not always 20 bytes. Fine. Why? Because Unicode characters may take more space. For example, H example, suppose HELLO. Okay, not this hello exactly, this hello. Okay, so what will happen now? Suppose for H, okay, takes 1 byte, simple. Then let me just copy this E from here, we'll just paste it here. This E, which is a Unicode, or it could be called as a spatial Latin symbol, this will take how many bytes? 2 bytes. Okay, 3, I, 4, then it's I again, then it's O. Fine, all of them are taking 1 bytes. But as per our understanding, hello should be of 5 bytes, but this is a spatial character with 2 bytes. Therefore, varchar with 5 byte will fail. This total is 6 bytes, correct? Because this is 6 and we are having 4. So we have to keep that in mind also. That is why in some platforms we have an varchar, okay, to handle this situation. But usually I have not seen this being used. Rather, what people do, this have uh, let me just write it here first, solution. But rather, what people do is that they make the size a bit bigger. Like suppose if they are pretty sure that there is nothing greater than 6, even after including the Unicode characters, they will put it as 10. Okay, so this is what goes on in real life. Okay, so this is one of the very important and unique point I wanted to share with you, because this will help you. This will make you stand out in the interview. So yeah, so I hope you got this. Let's move ahead. So I just wanted to share more about this blob. Okay, what is blob? It is not as much required, but I just wanted to give a brief so that people might have an idea. Look, today in today's world, no one uses blobs directly in MySQL or Postgres. Okay, but we should know the knowledge, right? We should have the knowledge. So we already know what blob stands for. So I will just write the definition here. It is a data type used to store binary data. Okay, not normal text. Basically, what happens that binary data means images of for different formats, audio files, okay, then videos, PDF, or I will just write documents, etc. Any file in raw bytes form. Okay, so what it does, instead of storing letters like hello, it stores data as bytes, which is zeros and ones. Basically, it stores the data in zeros and ones format, in binary format. Okay, so this is what I wanted to uh, inform you about, or let's give a knowledge about, because this becomes a complete different topic if I go into this. Fine, but since it converts the things sometimes in the form of string also, like zeros and ones, so I thought of giving this information here. So how it works? Okay, files converted to binary. Then SQL stores it as a large sequence of bytes inside DB. Then when retrieved, binary is converted back to original format. I hope this helps, right? Because I don't want to go much more in depth in blob because it is not required, and also I already gave you the disadvantage of using a blob in my previous page. Yeah, here, look, db blob efficiency reduces, takes a lot of time. That is why usually in today's time files are stored outside db. Okay. Basically in cloud storages or rdbms platform or different rdbs platform. Fine. Okay, so let's move ahead. Okay, now moving ahead, I want to give you the practical examples. Okay, you don't have to worry about anything because till now we are learning phase. We are not going depth into the syntax and what it does. But I'm pretty sure when I will write the query, you will have the idea. And we have not started, but till now we have not started the proper SQL query writing or scripting. We are learning the basics. We are learning the theory. We are learning the background of SQL. Okay, so that when we go and start practicing or learning, we don't have any issues on that. So let's create a table users. Okay, I guess I don't have this. And before that, use database school db, that is required. And don't worry about the syntax and query how I am writing it, but you might look into it and get an idea. But don't worry, I will teach you everything. Gender will be of char of size 1. Then this is the gender is the column name. Name is also a column name. It will be a varchar of size 50. Then description of text. Okay, and I'll just close it. I paste this and I will insert this data. Okay, now I will run everything. Okay, first line only gave me the error. So what is the error? Okay, sorry, we don't have to write database here. I will run everything now. Okay, and then select star from users. Look, description is there, right? And the name is there and gender is there. Now if I go to these tables and let me refresh it. Okay, yeah, users, columns. If I click, look, character size, var size, text size, everything is there, right? So it becomes easier for people to write and understand things. I'll just copy this and I will paste it here. Okay, looks good. So this was a basic practical example which I took so that you can have an idea of it. And you can run this code. This is a fully functional code. Okay, just remember to create a DB beforehand. That's it. So this is all about character and string data types, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is date and time data types. So from the heading, you can understand that in this particular video, we are going to learn and understand about the date and time data types in SQL, like how date are handled, how times are handled, how many seconds, hours, you know, day, night, everything is handled, right? So we are going to understand that in this particular video. So let's start with that. So first and foremost thing, let's try to write a definition here. What does it say? It says that date and time data types are used to store calendar dates, calendar dates, time of day, or both together. Okay, they are important in real world applications such as logging events, tracking order, tracking order, etc. Okay. So date and time data types are used to store calendar dates, time of day, or both together. They are important in real world applications such as logging events, tracking order, scheduling tasks, storing timestamp of records, etc. So this is where date and time data types are used in SQL and the purpose also. Okay, and what purpose basically it serves. And let's move ahead. And I have some uh, data types with me. I will just paste it here. So I pasted this table here. These are basically all the main main date and time data types. So we'll give the heading also main date and time data types. Okay. So if you can observe here, data type is date, format is year, month, and date. Okay. The range of this particular data type goes from 1001 to 999 to 27. So basically, it is nearly taking a nearly 10,000 of years, I guess. Right? This is a range, and it only stores date only. Okay, nothing else. If you come to the time, if you look at the format, it's hour, minute, seconds, and the range goes from minus 838 hour 59 minutes 59 seconds to positive 838 hour 59 minutes and 59 seconds, and it only stores time. So when we have to only store a date or only store time, we use this kind of data type. But when we have the date time, so here you can already see date plus time is date time, right? Simple as that. So here you can see, here is the date format exactly from here, and here is the time format exactly from here. Fine. And the range also remains the same for the date, but for the time it differs a bit. Look here, the date is exactly as the date from this particular type, but if you see at the time, it starts from 000 to 24 hours. Okay, so this is the difference. So it stores date and time together. Coming to timestamp, timestamp also has the same format as date time, exactly same, right? But if you focus here, it goes from 1970 11 to 2038 119. Okay, and this might get updated as we go forward, right? This is the current scenario of the range. Fine, and so currently this is the range, but in some other websites it might differ, right? But just approx, you can just take this as the range. Okay, it stores date and time with automatic behavior. So we'll understand this. Like as you saw, date, time, and timestamp has the same format, same range is different, but they look same, right? Then what is the difference? So this is the difference. It stores date and time. It also stores date and time with automatic behavior. So I will let you know what is this automatic behavior means. Then comes the year. Just 4 times 5, 19001 to 2155. Okay, and this range might again differ in different websites and different platforms. It depends, right? So you can just take it as an approx format. Okay, it only stores the year. Fine. So I hope you understood this. There was nothing too complex to understand here. Only this date, time, and timestamp uh, might create a confusion for you for the first time. So that also I will clear it out. Okay. Now I will just move to the MySQL workbench and show you some practical examples. Okay. And again, in every video, I tend to tell you that don't worry about the syntax. Just focus on what I'm trying to explain you and just try to understand that. And if you're curious about how I have written the syntax, you might Google is ChatGPT. Okay, but that is not necessary because here we are trying to understand the types, right? So that is why I'm trying to give you a practical example. So you because when we start with the SQL, right, writing SQL, you are familiar with the syntax. You don't get worried or afraid of it. So we'll create a table here named as employees. Let me see, do I have any previous table named as employees? I have to delete this. Okay, I have it, so I will just drop the table. Drop now. Okay, the table has been dropped. Okay, create table employees. Then here I will just give ID as int data type, name as varchar. We know both of their meanings. Then I will have a joining date as date. Okay, I will just insert into employees values one Rahul, and then joining date. Let me write today's date. Okay, 2025 6 03 12. Okay, I will run everything. Okay, there has been a mistake. Let me just see what is the mistake. Let me first create this. Okay, I forgot to select the database. Use school DB. Now it will work. Okay, we'll just run this. Okay, value has been added. Okay, so this is done, right? Now I manually wrote this particular time here, right? What if I have written here something like this? Current date. Look, I got these suggestions also, right? And I will just make it 2. I will insert again. Look, it got inserted. Um, and I will just click on this employees and look at the table. Look, we're getting both as the same date because this is the manually typed date, but this is the current date. Now, you might be confused like how did you use this particular thing, right? There are multiple common date and time functions which I'm going to explain you in this particular video only as we go forward. Just I wanted to give you a gist like how a date type is used. Okay, and I will also like to give you some information. I think I should give it in there only, not here. So we understood this, right? What I can do here is that I can just put it this way that it stores only the calendar date, which we already know, used for birthdays, joining dates, or any value where time is not required. Let me zoom this a bit. I guess now it will be clear to you, visible to you. Now let's go next to the other one. This was date. Now let's go to the time. What time does? It stores only time values, correct? Often used for durations, shift timings, etc. Okay, look, here we are putting the joining dates which we know, right? Birthdays which we know, but here the time is the duration, right? Which we know, but we have to put a minutes, hours, and seconds, right? So this is what is done here. I think that is much more clear. I don't have to explain there anything. Then I will create a table named as shifts. Let it be shifts. Employee ID, let it be integer type. Then let it be start time, let it be time, and end time, let it be time. Okay. Now what I will do, I will insert into shifts with values, bad values, ID 1. Instead of giving either I can give a time something like this. Okay. like 090000, then suppose 24-hour clock 180000, something like this, right? I can either give this way, or what I can do, rather than this, I can just pull here, put here like this, current time function. Okay, and also here I can put current time function, but this will of course give me the current time, right? Just run everything. Did it got created? Yeah, here. Look, the data is present here. The today's current time is this. Now start time, end time is same here, but we can just modify that. That's not a point right now. So yeah. So I hope you got this also, like how the time function works. Now let's move ahead with the, like, time is done. Let's go with the date time now. Date time stores both date and time. By doing this, I will give you the query also, right? And we will have some notes also, so that it becomes easier for you to revise and understand each data type, and you don't have to research here and there. Here also values remains exactly the same regardless of time zone. Okay, then we also have commonly, or you can say that commonly used for order date, because we need the date and time for the order, right? And when we log in, we need the date and the time along with it, right? And etc. Now let's write the query. Query could be like create a table name orders. Okay, let it be order id as int and order time as date time, and I will just insert into um, orders values 1 comma. What I can do, I can just put a function as now here. I will try running this. Okay, let's see what happens. Look, it ran successfully, correct? I will just refresh this. I can see now that there is a table named as orders, and we have this data. And if you can observe this, can't I zoom this? Let me let's get back here. Let's look year, month, date here, right here. Here also same year, month, and date. Then hour, minutes, and seconds. So hour, minutes, and seconds, correct? So this is the format. And again, this is a function. Okay, I will tell you about this. These are common functions which people use, right? So I will let you know about this. So date time is also clear to you people now. Let's move ahead to the timestamps. What timestamps is? Stores data and time like date time, but internally stored as Unix timestamp. Okay, very important. Automatically converts according to the server time zone. Okay, and often, this often, please keep this point in mind when you study. Okay, often used for records, record creation, and update tracking, and can automatically update when a row is modified. Okay, so for this, let's take an example. I will just copy this, paste it here, change the name to logs, and We'll just put it as log time, and this one also log ID, and this will be timestamp. Okay, default current timestamp. Okay, look how this is how it's used. Timestamp is basically used this way, and I won't be using this function here. Fine. I'll just comment this. Okay, it does not gets commented this way, and now I will run this particular thing. Look, the table is created. Refresh it. Is logs here. Look, there is nothing right currently, but now I will add some values here. What I will do, I will copy this, I'll paste it here, and I will just clear this also, and I will write that value here, logs, and it is going under log ID. Okay, now I will just update this. We'll run this query. Look, it went here. I will run this again. Value is present here, current time. Okay, then I will add more, 2, 3, 4. Now let's see, will it throw an error or not? Okay, and before that I will just give some commas here, and I will run this script. Look, it got updated, 4 rows got affected. Okay, we'll come back here. Please keep this time here. I will just copy this, I will paste it here so that we know what the timing was. Okay, I will run this query again. Look, id1 got added again. Why? Right, because I have not given any constraints here, right, like a primary key or like unique anything, but the time is different. Fine. So this is how a timestamp works. It stores data time like date timer internally stored as Unix timestamp, and also automatically converts according to the server time zone. Now, since the video is getting recorded from India, the time zone got affected according to the India. But if you run this query in your end, it will get affected according to your server needs, whether you are in USA, UK, Europe, or any time zone. Okay, and can automatically update when a row is modified. Suppose if this particular row one, now it's primary, right? Like it's only int. But if I alter this particular row or ID1, this time would be updated with the current time zone, and this will get updated. That means okay, replaced, I would say. So this is about timestamp. Now let's move ahead and understand year. And also you have observed with the timestamp that I did not add any timestamp here, right? It got updated automatically. So that is also a beneficial thing. Now let's move with the year. What does this do? It has it stores only a year value useful for manufacturing year, then graduation year, okay, etc. It's common actually, right? But since I have to add it, so I'm adding it. Suppose let's create something. Create table as, let's take cars, okay, and car name is Vaga 20 because we don't need much right now, and model year becomes the year. Okay, and I will insert into cars where values are basically Hyundai, suppose, and model year is 2001. Not this way, this way. Okay, and I will run all of this. Okay, it ran successfully. I will refresh this. Now if I go to cars, here it's cars, click on this. Look, it's 2001, right? What if control C, control V, instead of Hyundai I write here Tesla, and I give it a string? Will something happen? Let's check. it got inserted. We'll run this. It got inserted, right? So this way also you can insert, but since you have already defined that it's an year, so you should follow this method rather than following this, because this might give you an issue also going forward, that it might be considered as a string when you're fetching data from the database for a development purposes also. Fine. So let's so this was all about this everything I wanted to explain on all the data types of date and time. Now let's move ahead, and I've pasted this codes also here so that you can have a view from here. Okay, now let's move ahead and let's study about date, time, purchase, timestamp. Okay, when to use what? What I will do, I will just type it out. Okay, so that you can have a proper reading. Both date time and timestamp store data plus time, but they are used in different scenarios, right? Like based on whether time zone, based on whether time zone handling and automatic updates are needed. Okay, so both date and timestamp store data plus time, but they are used in different scenarios based on whether time zone handling and automatic updates are needed. Okay, I have a table. What I will do, I will bring that table here and paste it down. Just hold on. So this is the table. So you can just see here that time zone conversion in date time, it's not possible, whereas in timestamp it's possible, right? Like basically based on USA time zone, India time zone, UK time zone, etc. Fine. And the storage, it takes 8 bytes, whereas timestamp takes 4 bytes. Look, it's so much less. But since it uses so much less, it's not required that every time you will use timestamp, because what happens if you just update the particular row and the timestamp gets updated and you didn't wanted that to happen, right? So that's, so you don't do that cheap things because, or tricky things, because that's not necessary. Use date time wherever it is necessary. Okay, the range is from 1000 to 4 times 9, and it's 9070 to 2030, and this might get updated accordingly. And in some other platforms the value could be something different. Okay, so this is a kind of an average value, you can just take it as. Now it is used for real world date time, and this is used for system tracking and logs. Okay, so this difference should be fair enough and much more to you to understand, so I don't think anything more will be required here. Okay, now let's move ahead and continue this particular thing. Now let's try to understand when to use date time. Okay, use use it when the time should remain exactly the same regardless of time zone. Okay, this is clear, I guess. Now it should be clear. Like example you can take as event schedule. Okay, for example, if a meeting is scheduled at 10 a.m., it should not, it should remain, sorry, it should remain at 10 a.m. in the DB. Okay, because if the server time zone changes, suppose, okay, the value still stays 10 a.m. Suppose you entered today's date and time from India as 10 a.m. and when it is 10 a.m. in India, it might be some 12 hours difference or 6 hours different in different countries, right? That is why if I have put in the time zone exactly of India rather than putting it as 10 a.m., like suppose if I put it at today's time zone, right, using timestamp, I will get time, date, everything of India based server. But the person who is sitting in US or somewhere else, he might get confused that it's about that he will see that timestamp in his database, he will see it as something else, right? He will see it as his US timing of 10 a.m., then it will not be aligned. So that is why date time is typed as 10 a.m. will be 10 a.m. in my end also, and 10 a.m. in their end also. And along with that, we should also mention whether it is IST, CST, whatever it is. Okay. Yeah, it was not the best example, but I hope you're getting the points. The thing is, you should understand the feeling of what a person is explaining here, right? That matters the most. So meeting schedules, then it can be used in flight departure time, of course, event booking, then appointment systems. And some things are there when if even if you learn this, if you learn the theory, if you learn the concept, you might get confused. But when you use it in a practical world while coding something, then it becomes much more clearer to you. So don't get worried about these things if you are not able to grab it in at once. Okay. Now let's understand when to use time stamp. Okay. When to use it. Use it when you want the system to track when something happened and handled time zone automatically. Okay. Use it when you want the system to track when something happened and handle time zone automatically. What it means, let's understand. Example scenario, record creation time. Okay. Suppose Rahul created an SQL account at a particular time. Use timestamp there to capture everything based on time zone. Got it? I hope you're getting this point, right? Because date and time you have to manually add or fetch it from somewhere and put it there, something like that, right? Or you can use a date function also. But here, current date or not function, now function basically, not even current date. But in timestamp, you cannot use now function, right? Timestamp is suppose today, right now, if it is 9:43 p.m. in India. So if I just put that, if there is timestamp is as a data type there, it will capture 9:45 p.m. Okay, and it will store it there with the time zone with everything, right? So they will know the product owner that okay, at this particular time at this particular country this was the account was created. So this is how it works. Okay. So what could be the use cases? Use cases could be user account creation, login, logs, transaction, logs last updated time. Okay, and also I forgot to write here, so since it's a use cases, right, you should understand that use cases. Okay, next. So like here you can understand the use case, right? User account creation, it needed the current time, login logs, transaction logs, last updated time, and everything. I will just give you last one more example for the difference, as we have already seen the difference, but I just want to give another difference. I mean, since I will just paste it here, the query. I mean, we have already seen the example differences, but I want to give another one so that it's pretty clear to you. Time stamp purchase date time. Okay, I'll create this table. Got created. Now look, event name is SQL workshop, and the date and time which I am giving here is this date time. Okay, let this date time be 2026 year, month, and this. And today it's March, right? The day when I'm recording it, and I have given the time of nearly about after 1 month and 10 a.m. Okay, I will run this also. Now what I will do, will refresh this. We have the example table. We'll open this table. Look, event time is this, but the time when this event was created was this. Now it's clear difference, right? You can see it side by side. Okay, now what I will do, will just copy this. Okay, come back. Let's add one page and just add here, paste it. Okay, so this was the main difference between the timestamp and date time. Since I pasted the code here, so you can have a view. Now let's move ahead and learn some functions. So after understanding the differences between timestamp and date and time, sorry, date time and timestamp, I think it's a good time to make you aware about some of the important functions. Important date and time functions. These are the like these are the functions which we use 90% of the time, right? There could be some ups and downs and new functions could be come up. So I will as we go through the course, if something comes up, I will add it into the functions, right? Or I will just tell you about everything. Okay, first function will be, we write it like this, function and purpose. Okay, what I will do, we just bring the stylus, put it here, close this. Okay, now is a function, current date is a function, current time is a function, date is a function, time is a function. Okay, purpose is current date and time. Okay, it gives current date and time. Then it gives current date only, it gives current time only. Okay, it extracts date from a current timestamp, from timestamp, from current date and time, even from the current date, if there is a, if you want a day, month, all of those, right? Those things are there. Then there is this time, extracts the time. Okay, so these are the few important date and time functions which we use while creating the table, or while we using these data types, timestamp and date time. Like as you see, I used current date and current time to get students current date and current time, correct? And date and time is used for extraction purpose. Fine. So this is enough for now. As we go forward in the course, there is a different section talking about date and time, because date and time has a lot of functions in it and lot of variations. To use that, you should have the complete knowledge of the SQL, so that you can uh, understand and use those in different ways. So uh, this is all about the date and time data types, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is Boolean and binary data. So in this particular topic we are going to understand how boolean and binary data works in SQL, so that we can have a clear idea on those. Okay, so let's move ahead and let's start by understanding boolean first. Okay, boolean data. So let me write it as boolean data. Let's go with some definition first. Okay, so basically boolean data represent true, false values. Okay, it is used when a column only needs two logical states, such as yes, no, active, inactive, verified, not verified, etc. Okay, so this kind of scenario, if it is present, then we need the boolean data in that. Okay, so boolean data represents true, false values. It is used when a column only needs two logical states, such as yes, no, active, inactive, verified, not verified, etc. I hope you understand these things. That is not so much complex, I guess. Okay, now let's try to understand more further. I will type it out. Usually boolean data represents logical values, like two logical values, right? But I will tell you one more. Okay, there is true, there is false, and there is sometimes unknown or null. Okay, means missing value. Sometimes, not every time. Usually it is true and false only. Okay, now let's go with the common use cases. Okay, so first would be status flags. Okay, second one will be conditions. Third one will be yes, no fields. So it basically represented as is active, and this is represented as is deleted, and this is represented as has paid. So what you will say is active, you will go and say like true or false, right? Is active true or false? Correct. Is deleted, again true or false? Has paid, true or false? So yes or no, no or yes, yes or no. I hope you got this point, right? It is pretty easy to understand this. Now moving ahead, how SQL stores boolean. How they how basically SQL stores the boolean. So one thing is here, like different DBs handle it differently. Okay, clear? If we focus for MySQL, as we are learning in MySQL workbench, but in MySQL, boolean is just an alias for tiny int. Okay, like 1 stands for true, 0 stands for false. Got it? I hope you got this point, right? What I'm trying to say here is that boolean is just an alias for tiny int in uh, MySQL. But tiny int stores only one integer, right? So Boolean becomes that because Boolean stores the values in the form of zeros and ones. That is clear, right? Or true or false, something like that. So I will just give you an example here. First, I will delete this table, drop table. Yes, great. I will just what I will do. I will create table named as users. Okay, and it will have id as int, and is active will be a column with the type as boolean. Fine, and I will run it. So the table has been created. Where is it? It is present here. Okay, columns also you can check. If you can check here, look, id int is active tiny int. Look, but we wrote boolean here, right? So how it's tiny int? So that is what it is. Within MySQL, this gets changed to tiny int. It's an alias. Now, if I just try to insert the value, suppose insert into users, values would be 1 comma suppose true, copy paste. Okay, and let it be false. Okay, and I will run this too. Okay, I think this might be the reason. Okay, okay, great. Now I will just click here so we can see the data. Why didn't this got inserted? Okay, we'll run this again. Look, id1 is active 1, id2 is so it stored the value as 0 and 1, right? As we discussed here that boolean is just an alias for tiny int in MySQL, and might be the same scenario might be in Postgres or Oracle also. You might not, never know, but syntax is boolean, right? And usually boolean is stored in the form of 0 and 1. Fine, fine. So that is what it is here, 1 and 0. For 1 for true, 0 for false. I hope this makes it clear. Now let's take another example. Suppose insert into users values 3 and let it be null. Okay, let's see what happens. Look, got inserted, right? But how, being a boolean or tiny int, we could have the null value in it, right? I will just try to select this user from this users table, and I will run it. Look, null. So what does this says? This says that, another note, boolean fields can also be null. Okay, so this is the another you can say a knowledge which no one tells you about when they are teaching this particular course of SQL. Like, boolean fields should be can be null, and you should be knowing about that. If an interviewer asks you, you might get confused because you might be only knowing that 1 or 0, true or false, this or that, right? But not this. So this makes a different one. Okay, so please keep this in mind. Okay, so this is all about the boolean, because it is what it is. There is nothing else, right? I won't be stretching this topic unnecessarily if it is not required, because this is what it is. You just have a column, you just name it as boolean, and this is what it is. But yeah, uh, if I can give you a few exceptions, like suppose you saw right here that it went as 1 and 0. It got converted to 1 and 0. What if I just copy and paste this here, and I will make it 4, and I will just remove it, and I will make it 1, and I will run this. Okay, it got run, right? So I will come here and I will run this. So 1 is there. Fine. Now I can tell you one more thing here. Like, this is fine. Okay, so we'll just paste this here, and what if instead of true, false, or 1 or 0, which I know, I just put 2 here, and here I just put by mistake -3. Okay, and let it be 5 and let it be 6. I will run both of this, but it got inserted. Why? Because if you come here and see, we'll run this again. those got inserted. Look, uh, first in MySQL, we know that Boolean is tiny int, correct? Technically, we can store numbers, right? That is why, or therefore, MySQL accepts numeric. Just copy this and paste it here. Okay, I hope you got this. Coming back, but logically we know that 0 is false and any non-zero is true. Okay, but if you go in a Boolean type, right? Boolean means 1 and 0, but true is basically any positive number. If you go globally also, like uh, what I can, rather than writing globally, what I can write overall, I will just write as overall. Okay, overall 0 always means false, always. Okay, but 1 is basically any uh, non-zero, or I would say as it is true. Okay, uh, it should be true, not 0. Okay, this should be always. So this is like a global, overall globally, I would say globally. Okay, so this is another thing. Okay, so I hope you understood this particular thing. Now let's move ahead. Now let's try to understand uh, binary data. Like Boolean is done. Now let's understand binary data. Okay, so binary data types stores, like in the previous video or the previous topic which we studied, right? Characters and strings. There also I talked about binary data, right? So here also I'm giving a brief about that so that you could have a knowledge of it again. So types store raw byte data instead of characters, right? Everyone knows this, not a big deal. They are used uh, to store, suppose, encrypted data, hashes, images. This is basically blob. Okay, files, again blob storage, basically binary identifiers. Binary identifiers. Okay, so like from the previous topic only you might have got the idea of binary data here, so I just given a same thing in a different way, right? So that you could have a clear idea. So I will just paste this here. So yeah, so what is this? This is binary data types in MySQL specifically. Okay, because in different platforms there might be a different way, right? Since we will be practicing everything in MySQL, again I'm saying that that is why I'm focusing on this particular binary data types in MySQL. Okay, so for binary, var binary and blob. Binary is for fixed length binary data, variable length binary data, and large binary objects. Okay, so blob you might already know from the previous topic. Now let me bring some text here like this. Binary, okay, these are fixed size. Okay, if data is shorter, it is paired with 0x000 bytes. Okay. For example, suppose if there is a create table, okay, device, then if I write here, suppose device code in binary, we'll write it as binary of size bytes 4, and I will insert the data, suppose insert into device values would be suppose something like AB, AB, okay. So how it is stored internally? Stored internally as AB /0/0, okay. So this used up a extra space, right? But if you go with var binary, if you can just relate this thing with character and varchar, char and varchar from that particular topic, then this is a simple same difference, right? Same difference. It will be a variable length, of course. Variable length binary storage, like similar to varchar, but for bytes. Okay. For example, if I take this exact same table, we'll copy this and I will just paste it here. Okay. And instead of binary, I write here var binary and give a size of 32 and DEFG, something random I gave, right? So how it will be stored? Stored internally as this, right? No difference, no extra padding or such. Got it? So these are the two main differences or in-depth knowledge about binary and var binary. Let's move ahead and also understand the same for the blob. Okay, blob. I know you already know about blob. You are smart. You have studied from the previous topic, but again, let's look into it. Binary large object. Okay, it is used for large binary data like images, files, etc. We know that now. Now, then, what are the types of blob? We'll just paste it here. Okay. Okay. These are the types of blobs with the max size that it can handle. Now, if I take an example for you, suppose create table files. Okay, and let it be id int and file data to be blob. Fine. So this is how it will be stored, and in the background it will be just stored as in the form of binary, like I guess like the 0 1 1 1 1 1, sorry, not 2 2 2, something like this. Okay. So let's go in here, and this was about Boolean, right? So what I will do, I will just copy this. Wait, I will just copy this and I will go back previous. Okay, I will add a page here and I put this here so that you can have it. Okay, the code is present here. Okay, so that you can relate this particular thing with this. Fine. I should also put the output also, I guess. So you can have this for your understanding. Let's move ahead. What I was doing. Okay, again. Okay. So I will just clear this up, clear everything. Now we'll create a table. Create table binary example, and I will just write here fixed code binary with size 4, then variable variable code with varchar something 32. Again, I will write file data blob. Fine. I will create this table. Table got created, and also I will clear this. Wait, clear. Okay. Then I will insert into binary example values. Suppose AB, then hello, then binary data 123. Okay. Why it threw an error? Because I didn't. Okay, because I didn't close this. Now we'll run again. Values got inserted. Great. I will refresh this. I'll come here, click on this. I can see the data. Look, it is showing here blob and hello and blob again, right? If I just come back here and I will just put this here, I will remove this. I will click on enter. Look. So this was the example. I will come back here and paste it here. Okay. So you can refer to this particular example. So this was it about regarding this particular topic. Okay. So this is all about Boolean and binary data, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is understanding null values. So in this particular topic, we are going to understand what is null values and what are the myths or what are the wrong assumptions students or sometimes people take on null values. We will try to clear that also, and how we use null values in SQL. So we'll basically try to understand this in an overall pattern. Okay. So let's start. So before starting, I would just say null is one of the most important and most confusing concept in SQL. It is confusing until and unless you don't understand what is null. Okay, but after that, it's not confusing. But sometimes it gets confusing. Yeah. Okay. So let's move ahead. Let's start by understanding null values in SQL. Okay. So we'll try to give some important notes to you. So I will just write it in a text manner. Let's start by understanding first what is null. Okay. In SQL, null means missing, unknown, or not available data. Okay. So this is the meaning of null in SQL. It does not does not mean zero, empty string, or false value. Okay. It simply means no value is stored. That's it. Okay. Nothing complex. For example, salary is a column and it is assigned to null. What what do you mean when I say my salary is null? Is it zero? No, I didn't say my salary is zero. Is it empty? Empty string? No. Is it a false thing? No. Salary is null means in that particular column, I have not stored any value. Got it? That means it's unknown. The value is missing. it's nothing there, right? Something like that. Not, it's a, I could say it as missing, unknown, or not available data. Not, it's not zero, neither false, not empty. Please keep that. That's the thing where, this is the main thing where people get confused, right? So I hope you're getting it. So what it means, it means salary is unknown, okay, not zero. Because if I write zero there, it will directly mean that the salary is zero, the person does not earn anything, right? It is simple as that. But it's null. Null means there is a column, or it's something like, if you have a box, so I would say the box is null because the box is null. Let's understand box as a, let me just write it here. Take this, take this as a box, okay, as a variable, okay, and if it is empty, I would say the contents of the box are not there, okay, but the box is acting as a variable, which means that the contents, okay, contents of the box is missing. I didn't say it's zero. If I say zero, that means there has to be something, and now it is not there, or there is something which is zero, something like that. Getting my point? I know it's a bit confusing, but yeah, bear with me. Or I would say it's unknown. We don't know what was in the box or what would be in the box. So I hope you are getting this. Okay. So box is acting as a variable here. So let's move ahead. Now we will say, since it does not represent anything other than missing or unknown, why uh, then why null exists? Okay. Why does it exist? If it does not means, and if it does not mean anything, why does it exist? So let me clear that also. Null is used, okay, when data is not provided yet, okay, because we created a column, right? So we have an assumption that in future there might be a data. Currently it does not have any data, but in future it might, there might be a data. Suppose hers is an employee which is on the hiring process, but for 2 months the salary section is null, but in coming third month he will have the salary, right? So that won't be a null, either it will be a zero or more. Fine. Then value does not apply, okay. Sometimes we try to store something somewhere in a column and it's not getting applied, right? So there could, that might be also the reason that I try to enter zero, but it did not get filled there, so it became null, okay. Third, value is unknown. Suppose I don't know the model of the car, so we'll skip that particular column, model column, so that becomes null, not zero, not empty string, nothing. Null means we did not put any data there, or we forgot to put the data, or we don't know the data. You getting my point? And if I take the example, let's take an example. Suppose a student may not have a phone number, correct? But in future he might or she might have a phone number, right? But for now, the phone number becomes null because he or she don't have the phone number currently, right? So it becomes null. If I write it zero, that means his or her phone number is zero. If I give an empty string, that means his or her phone number is an empty string. So this is how a null is different from those of what we think of, correct? Now let's move ahead. Now you will be having a doubt that I'm saying that null is empty, but not empty. It's unknown or it's missing. There's a difference. So let's just let me clarify that also. Null versus empty value. Okay, let me clarify this also. Suppose let me give a heading here: value type and the meaning. Fine. Null. Value is unknown or is missing. Correct? If it is just an empty string kind of a thing, value exists but is empty. Okay. Third, zero. Value exists and is zero. So this is the clear picture. Null, value is unknown or missing. Value exists but is empty when there is just a empty string or something like that. And zero, value exists and it is zero. Got it? So this clears the thing. Nothing to explain here. Now what I will do, I will go back to the MySQL workbench and give you some examples, practical examples, so that you can understand. And again, I will be saying the same thing. Don't worry about the syntax and queries. We will study everything. Right now, just focus on the concept and the theory and the knowledge behind everything. Okay. And if you are curious to learn how it's going, it's simple, right? So you can understand or you can just Google it. So let's move and just create a table. Create table employee. Okay. What I will do here, I will just paste this script here, okay, and I will run it. But it will throw an error because I am not using a database. So using, oh sorry, use school DB, and since I already have an employees table, I guess. Let me see. Okay, I don't have. Oh, I have it here. What I can do, I will just keep it as employee, not employees. Let's see now how it works. I will run this. Okay, spelling is wrong here. It's underscore DB. Now I will run this. Okay, the table is created. Then I will insert the data. So here you can see the salary section is null, the bonus section is null, multiple nulls are there, last three values, and the last two is null, right? So I will run this. There is an error. Column does not match value count at row 1. Of course, because my table name is employee, not employees. I will try again. It got inserted. Now what I will do, I will just refresh this. Employee table is here. We click here to get the table. Look, we have the table here, and I will zoom this also. Just a sec, and I will zoom this also. Okay. So here you can see the data, right? So some are null. Here this one is null. This is null. This is null. This is null, right? And okay, so just we create a table. Now let's move ahead. Now let's check some of the uh, exceptions. Okay. So I will write it as exceptions. So first exception is null is not equal to anything. Okay. How? Suppose let's select star from employee table, where salary is null. So what should happen? Let's check. It did not return any row. It's an empty table it's returning. But if you check here, salary is null is present in employee ID 2 and in employee ID 4 also, and yeah, in two, these two should be returned by, right? But it is not returning. But if I write select same thing only, I will just copy it, and instead of null I will write is null. Just close this. Now we'll run again. It will show me this ID 2 and ID 4. Why? Because null is not equals to anything. If I say for example, there is a row which in which the name of the person is null, means it's missing or it's unknown. So how can it given equal to, right? That's not possible. You cannot just equal them, but rather you can say that please look for something which is null, right? Which is null. So it goes and check for the columns which has nulls, right? So we'll write it as resolution and mistake. Now let's take another example. I will just copy this itself. It's an exception to, it uh, is not null. Okay, paste it. I will write where bonus is not null. Now from above you saw that if I write this, uh, it will not throw an error, right? Or it might throw an error, right? But let's see what happens. It gave me an output, right, of where the bonus are not null. Fine. Then let's check this null versus calculation. Okay. Before moving ahead, let's come back here and now note one thing. Null in calculation. Note this. Okay. Any arithmetic with null. I hope you understand arithmetic, right? Gives what? Gives null. Suppose if I do select 100 plus null, this will give me result as null. How? Let me show you. Select 100 plus null. Okay, let's see. Okay, I have to close this, run this. It's giving me null. But what if I do 10? It's giving me 110, right? So both things are clear. Why? Because you know the reason. Because the value is missing, right? If I say there is a well, 1,000 feet deep, so you don't know what is there, right? It's completely black for you, blackout and something like that. And if you just throw a 1 rupee coin, what output are you going to get? Do you know? Is there any how many coins are present inside the well? You don't know, right? So for you, it becomes null, right? Because you don't know. So $1 or 1 rupee plus the null becomes null for you because you don't know that whether it got updated or whether it got subtracted or whether the value reached there or not. Something like that. You can just take that example. I know it's not a good one, but yeah. Also, null in aggregates. Aggregate means summing, average, count, etc. Like aggregate functions. Okay, like min, max, and all those. So what happens? Sum, and don't worry about this function. Sum means takes the sum of the values. Average means take the average of the value. Count means count of the rows, etc. We will study all of this, but I have to explain the concept, right? So just ignore the syntax and the meaning. Sum and average ignores null. Okay, and count column ignores null. Then count star counts all rows. Okay, now let's look at the example. Now these things which I'm teaching you, the myths, the issues, the differences between null, empty, and all those, and some examples and some exceptions, these are not taught by most of the people while they're teaching you the null topic. Sometimes they skip the null topic and they don't go in depth. So this is what you should know. This stands you out in interview, in your job, anywhere, right? If you're teaching someone, if you want to understand more in depth, so these are the things which you stands you out, right? So I already gave you one example. Okay, so let me give you more example. Suppose select Okay, we're selecting name column, salary column. Okay, we're selecting bonus column, and then salary plus bonus we are adding as total income. Don't worry about the query. Okay, don't worry about anything. Just look. It's like an English. Just read it like an English. Okay, employees. Now we'll run this. Okay, we'll run it again. Salary. Sorry, it's not employees. It is employee. And let me clear this also. Clear. Now you can see the correct outputs. Look, 55,000, 50 plus 5,000, 3,000 added with null gave me null, 4,000 with null gave me null, null with null will give you null, and here is the value. So you got the total output. So this is how it works. Right, fine. And also, if I just try to give another example, um, suppose select count of salary. Okay, let's take salary from student from employee. Okay, let's see what happens. So if I run this, you can see 3, right? But if you remember how many rows we had 5 rows, 1 2 3 4 5, but the null ones were ignored and these 3 were taken, right? So this is how null value works with the aggregate functions or calculations. Fine. Null versus calculations, and also I will just write here and aggregates. Okay, now let's move ahead. In MySQL, now let's, since we will be practicing everything in MySQL, let's just see one more thing for MySQL. Handling null using if null. There is a function called if null. Okay, let's see how we handle scenarios with this. So I will paste this query here. Okay, and I will run this. Look, I've used here if null. Okay, let's run again. Okay, it has to be employee. Look, total fixed income. Now you can see that when I ran this query, let me run this in different cell. I will just copy this. I will paste it here. Okay, okay, and I will run this query. Look, here all were null, right? Because the values were null. But using if null, now look, this if null can be used in different platforms also, but we are considering MySQL here. If you are using if null, so you can understand it this way. If salary is present, then please take the salary. Like in this case, 5,000, 50,000 is present, then take 50,000. If salary is not there, make it 0, not null. Okay. Similarly, bonus, similarly, salary. If salary is present, take salary. If we don't have salary, take the alternate value, which is 0. Okay. And after that, I'm adding all of this. Fine. And then returning it. That is why we're getting the values here. It will be 0 because everything is 0 here. Fine. So this is how you handle null values in MySQL or any other platforms you are working on. There is another one. I don't want, like, that does not make sense here, but I just wanted to give you or tell you, like, it's a function coalesces, which is a function which basically helps in getting the first non-null value. First non-null value. Okay. Select co. Okay. I will just take salary here. Okay. Salary from employee table. Okay. Look, it returns the. Wait a second. If it is salary, then I will just write it here. Not available. Now it will make sense. Look, wherever there was no salary or it was null, it was transferred with this. Okay. With not available. So this is how the coalesces work with the null values. So wherever the null is, if you want to put some values there, either you could use this, and yeah, that's how you can do it. Now I will just there is another one. It's a bit advanced, but I just want to give it to you. Like just wanted to complete everything, not to leave anything. In joins, okay, null in joins. or null with joins, I would say. Null in joins or with joins. Okay, whatever suits better. So I'll paste one code here. Okay, I will close this result also to make some space. So I am creating a table here with department ID and department name. This is a primary key which I talked about in previous videos. Just don't worry about that because you know the concept, so don't worry. Now I'm inserting these values here. Okay, so we'll create this table. Okay, then I will insert this value. Okay, now what I'm trying to do here, I'm taking the name from the employee table. Okay, and department name from this departments table. Okay, I'm doing a left join. Basically, suppose you have a left hand and you have a right hand. So left hand is a base hand which has everything. So just take it as that way. Or okay, you can take it as this way. Like you have a bread in your left hand and you have some veggies and uh, whatever thing you eat, you have it in their left hand with the bread. Okay, one slice of bread. And in the right hand side, you have a bread with ketchup. So when you bring the right hand to the left hand, they merge, right? The ketchup goes wherever there is empty space, it gets mixed up and something like that, right? So this is how the joins work, right? So wherever there is an empty space, ketchup will flow there, right? And if there is an extra ketchup, it will fall out, right? And if there is no extra and some ketchup will still remain in the right hand side in the right the slice of the bread. So this is an example I tried to talk to make you understand. So this is how it's going to work. Okay, so what I will do before running this, please look at this data. Look at this data first. Okay, okay, now come back. Now we'll run this. And wait, let me just select star from departments. So department data is this. Okay, so we'll close now. Now we'll do this. So here left hand is your employee table and right hand is your department. Okay, now what I wrote here, that please do the left join or do this combining where department ID matches in both of the sides, right? Because here also in employee table you, okay, look, here we had the department ID, right, in this table, this three, and here also we had the department ID, right? Look here, 101 102, and here also we have 101 two times and 102. Okay, so what happens when this join runs? I will just take the department ID also, so it will help to understand. Department ID. Now we'll run again. You could see 101 was there with Amit, HR department. 102 was with Neha as IT department. 101 Raj with HR department. Correct. But in employees table, Simran and Karan did not have any department, right? Look, Simran and they did not have any department. That is why it did not got any department name also. So since here in the employee table we did not have these department IDs, and the right hand side table which is department had the department ID. It's a joint concept which I don't want to go in depth here, but since left table has all the data, like left table has to be there, everything has to be there. From the right, like take the example of the sandwich, right? The right, everything will come to the left, like to merge. But whatever data does not match from the right hand side to the left hand side, so those data from the right hand side becomes null. So this is what it's happening, right? It had the data, right? The right side had the data, but left side didn't had the data, but it had Simran and Karan, right? This is the left hand side data. So it came here, but since it was not present in the left hand side department ID, sorry, that's why it became null here and also became null here. So this is what how it works. So if you go and make more joins, complicated joins, you will get to know more, but these are the basic things you should be knowing. Okay, I will attach this into the script, so that I will do, so don't worry about that. Okay, so this is all about the topic understanding null values, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is common data types mistakes. So in this particular topic, we are going to understand, of course, what the heading says, the common data type mistakes which people do because of the reason they don't know the background of what to use and what not to use, or when to use and when not to use. Okay. So we'll try to give the most common ones or the most important ones so that you could have an idea of it. So let's begin. Let's begin with first one, which is uh, there is no explanation in this particular video. I mean, not going in depth. It's just understanding the things. Like first, using in data type for phone numbers, right? You would say it's correct, right? Using phone numbers is fine, but why in integer data type? No, you are not supposed to use that because uh, if you're using int as a data type, what will happen? The problems I will write. Problems would be first one: phone numbers are not numeric values for values for calculation, right? We are not doing any calculation with the phone numbers, correct? Second, you cannot store leading zeros because of this. If you remember, some phone number have leading zeros, right, as their code. Postal code, I guess it is called as postal code or state code, whatever it is. So some might have 00 in beginning, so it won't database won't be storing that. Okay, if it is an int. Okay, some countries have plus sign also, correct? And sometimes they also have or brackets. Sometimes they have, right, brackets uh, or more than int range, whatever the range is of int is, I guess 127 negative to positive 128, right? If they have more than that, then it might be an issue. So the correct is using varchar with 15 range at least. Okay, I hope this writing this way makes it much more clear for you to understand, because these are a kind of pointer things. I don't have to go in depth to explain these scenarios. That's why I'm writing this way. Okay, and here I can write like phone numbers phone numbers are identifiers, not numbers. Second comes using varchar for numeric calculation. This is the biggest mistake people do. I don't know why they do it, but it is a common one. Okay, so since it's a common one, I will discuss this. Problem becomes implicit conversion happens. Second, can cause unexpected results or slow queries. Of course, you're multiplying a number or doing calculation on a string kind of a thing. Varchar is kind of a character of string, a string of characters, right? So because this becomes an headache for the persons. Okay, for example, if there is a string as 100 a, okay, you multiply it by 2, it will give an error. Okay, that is why the correct thing is using decimal. Okay, 10 comma 2 is an example of 10 comma 2, because numeric numeric calculation should always use numeric data types. Fine. Okay, let's go with the third one now, which is using float for money. Okay, like salaries, bonuses, etc. What happens? uh, I will write here problem like this. Problem, what happens is that if it is stored as 19.99, okay, but when calculated, like select star, select price into 3, result will become 59.969999, which is not good. So the correct structure is using decimal. Okay, reason float is approximate precision. Money requires exact precision. Okay, that's why. Let's look at the fourth one, which is storing dates as strings. I hope this is not getting bored because these two, three laws are there. So you cannot go and fight on it because that logically makes sense, right? So same here. You have to follow this. You have to know this. There is no extra thing I can come and explain to you, right? Build up anything from my own. This is what it is. So I'm just typing it down so you know everything, because you might not find it in the internet or in any other kind of videos, because I have not seen anywhere people explaining these things in depth, or not even in depth, but just giving the points also, right? So that is why it might look some boring, but it is what it is. Okay, so let's continue. So what is the problem here? You're using dates as varchar. Okay, now what will happen? Inserted as, suppose events, in events column you just inserted as 10 um 03 2026, correct? No issues, right? What happens is that, what happens when sorting happens, sorting of rows happens, select star from events, order by event date. Okay, uh, inserted as event date. Okay, output becomes like 01/01/2025. Okay, because it's in ascending order. Default sorting is in ascending order. Okay, 03/2026, 02 dash 02/2024. Look, this becomes the output. So the correction is using date. Okay, because date types allow proper sorting, filtering, indexing. Now here why this output came, because it's stored in string format, and what will happen in the background, it will go for the ASCII uh, changes, ASCII lookups, like they will follow ASCII value. Okay, or like what is the value of ASCII of 01, that 01, whatever, it will go that way, like spatial characters and everything. Because of this uh, sorting will affect. Okay, that is why issue happens. Okay, so let's move ahead with more points. Let's look at point 5. It says using char instead of varchar. Problem here is, if suppose name is char of 50 size, fine, and its value is Rahul. So what will happen? Database stores it as Rahul, okay, plus like 1 2 3 4 5, right, plus 45 spaces. Okay, so it took extra space, so 45 bytes, I would say, or space is used unnecessarily. Okay, so the correct part is using varchar because char should be used only when length is fixed, as varchar are dynamic. Fine. Now let's go to the sixth point. Ignoring unsigned for positive numbers. Like problem becomes this, like um, quantity is of int type and unsigned. Okay, sorry, it's of only int. Okay, so if negative quantity is entered, it will not throw any error leading to wrong result. So correction becomes, because quantity cannot be uh, negative, right? It cannot be negative. So correction is quantity int unsigned. Okay, then will store only positive values and prevents invalid data. Fine. Let's look at the seventh one also. Boolean stored as string. Problem becomes you storing values, storing Boolean as strings like true, not standard protocol. So result comes out to be true, false, yes, true, etc. Right? Correct is using Boolean, okay, or tiny int in MySQL. Okay. Now what else we can see? Using date time instead of timestamp. So we clearly understood the difference between date time and timestamp in our previous topics. Okay, in our previous topic on date and time data types. So from there you can understand this. Like for system events, okay, the problem becomes timestamp, or I would say this is the problem. Problem is like there is no problem actually. They just do the issue. So I will just write it as why, because timestamp is time zone aware, automatic updates, good for logs, okay, and date time, like for it is for static values, better for historical events. Fine. There remains one more, not handling null properly. If you have watched my understanding null values topic video, this will be easier, or I would say this will be much more familiar to you, because problem becomes if suppose bonus column is saved as null, but you are querying where bonus equals to 0, output will be empty. So correct is, if you don't know what it is stored as, whether 0 or null, query using where bonus is null or bonus equals to 0. because null means unknown, not zero. Correct? So these are, or this where, like there are many. Okay, there could be a lot of common mistakes which people do, but these mistakes are quite we could say like day to day. Like if you are new to something and if you forget, then these are the few mistakes you would be doing. There are some advanced mistakes also, but for that advanced mistakes you have to be in an advanced position. You can take it in that way, but even those people also do this small mistakes. So learning from these common mistakes only, you can avoid the advanced mistakes, because the advanced mistakes are made on the bricks of the small mistakes or the common mistakes. Fine. So this is a list. I tried to type it down so that it's easier for you to revise it. Okay, and if you find any more common mistakes, do let me know. Okay, so this is all about common data type mistakes, and I hope you understood the topic. Thanks for watching this module. Check out the next video in the beginners playlist. Explore other related modules there as well. Don't forget to like, share and subscribe.